Hello everyone. Today we are going to solve the second question of the math paper of JEE Advanced 2025. The question is as follows. There are three students. Their names are S1, S2 and S3. And we are given four events to consider. Event U is that at least one of S1, S2 and S3 can solve the problem. Event V is that S1 can solve the problem given that none of S2 and S3 can solve the problem. Event W is S2 can solve the problem and S3 cannot solve the problem. And event T is S3 can solve the problem. And we are given three probabilities. The probabilities of U, V and W as PU is half, PV is 1/10, PW is 1/12 and PT is unknown. We have to find PT. So in this case, we will consider the axiomatic definition of probability. Everybody please note down the question because I am going to rub it. So the board is a little dirty. I am going to improve it later. Okay, just bear with me for today. Sorry. Okay, it cannot get cleaner than this. So we will start with the concept of sample space. Our sample space consists of three elementary events E1, E2, E3. E1 represents that S1 can solve, E2 represents S2 can solve the problem, and E3 represents S3 can solve the problem. So rewriting the events that we were given in terms of E1, E2, E3, I will also denote this event E2 union E3 by A. Okay. So after setting up these definitions, I will rewrite the events U, V and W as U equals E1 union E2 union E3 equals E1 union A is defined as here. V equals the conditional event that S2 S1 can solve given that neither E2 nor E3 can solve. This is E1 given that E3 complement intersection E2 complement, or we can write this again as by applying the law of complement. We can write this as E2 union E3 complement. These two are equal. Okay, and event W is simply uh, S2 can solve and S3 cannot solve. That is E2 but not E3, which is simply E2 intersects E3 complement. So I am going to rub it again, and I will rewrite the probabilities in terms of E1, E2, E3. Okay, and please keep in mind that A denotes E2 union E3. Okay, so the first probability we are given is of event U, which we rewrote as E1 union A. So we are given E1 P E1 union A equals half. This is equation 1. P E1 given E2 union E3 complement equals P E1 given A complement, which equals P E1 intersect A complement on P A complement. This is from the definition of conditional probability, and this equals 1/10. So we are going to rewrite this as 10 times P E1 intersects A complement equals P A complement. This is our equation 2. The third event whose probability we are given is W. Which is simply E2 intersects E3 complement. PW is, we wrote earlier, E2 intersects E3 complement equals 1/12. This is our equation 3. So you should note down these equations because I will have to rub it again because the board is not very big. So I'm going to erase this. Okay. So from equation 3 we get we know that P E3 complement equals P E2 intersects E3 complement plus P E2 complement intersects E3 complement. So from equation 3 we substitute the value of E2 intersects E3 complement. We get this from equation 3 and we substitute its value from 3 as 1/12, and this is simply A complement. This equals E2 union E3 complement equals A complement. So we are going to rewrite it as P of A complement. And this is simply 1 minus P of E3. So we will rewrite this again, 1 minus P. So we got all this from equation 3. So, and we will rewrite this as PA complement as 1 minus P of A. Okay, this 1 gets cancelled, and we take the probabilities to one side, and we get P of A minus P of E3 equals 1/12. This is our equation 4. Okay. Now we will use the second equation. We were given P even intersects A complement. 10 times P even intersects A complement equals PA complement. 10 times P of even intersects A complement equals P of A complement. This was our second equation. How do we get from this P even? P of even minus A. So P of even equals P of even intersects A plus P of even intersects A complement. We will substitute the value of P even A complement from here to here. Okay. What this gives us P even intersects A complement equals P of even minus P of even intersects A. Okay. So this was our equation 2. We'll substitute the value of P of even intersects A complement here, and P of A complement equals 1 minus PA. We will substitute this value here. So what we will get, 10 times P of even minus P of even intersects A equals 1 minus PA. And this is our equation 5. There are lots of equations. We are going to use equation 1. Equation 1 is P of even union A equals half. Now I am going to use the inclusion exclusion principle to rewrite even intersects A. This equals P of even plus P of A minus P of even intersects A, and this is given as half. We will take this to the other side, and we get P of E1 minus P of E1 intersects A equals half minus PA. And we see that these terms appear here also, okay? So if we take this 10 to the other side, we can substitute this expression's value from equation 5. And we get 1 minus PA upon 10 equals half minus PA. From here we can solve for PA. If we do all the arithmetic, we get PA equals 4 upon 9. And what did we want? We wanted the value of PE3, and PE3 appears with PA in equation 4. This is the equation 4. Substitute 4 upon 9 here, and we get 4 upon 9 minus P of E3 equals 1/12. And solving for P3, we get P3 equals 4 upon 9 minus 1/12 equals, the common multiple of 9 and 12 is 36. So it will be 16 minus 3. That is 13 upon 36. And this is the answer. I don't know. It's the option A. Okay, so this problem involved a lot of calculation, and I think some questions do demand lots of calculations. Okay, the board got very dirty. I'm going to stop it here. For the next question, I have to clean it.